Hi, and welcome to our Matlab tutorial. This lesson's on anonymous functions, how we can create them in a Matlab environment, and how we can manipulate them and plot them. So anonymous function is a function very similar to a user-defined function, but it's actually a function that we create with variables. Variables that can be used as inputs to solve the equation, either in a script, in the command window, or in another function. It can include any built-in or user-defined functions as well when it's being created. The expression must be written to the dimension of the argument. In some cases, it may require element by element or matrix-wise. Anonymous functions can also include predefined values. For example, if your anonymous function has a variable, let's call it variable y, y can be a declared variable in your workspace before you use it. The nomenclature for an anonymous function looks something like this. fname, which is the declared variable, is equal to the @ symbol. That @ symbol tells Matlab that this is an anonymous function, and in the parentheses right after where it says arglist or argument list is where we will list all of the independent variables that must be inputted to the function at a later time. And then after the parentheses is the actual equation. So it might look something like this. We'll define an anonymous function as being the name cube xy. We'll say it's equal to telling Matlab it's a anonymous function, x comma y. This means that this function requires two inputs to solve. If we look at the actual expression, it's simply equal to x cubed plus y cubed. Once we hit enter in the Matlab command window, Matlab is going to save this function so that it can be used at a later time. When we want to use it, we simply treat it like any other built-in function with the inputs required. In this example, we'll say cube xy with inputs of 2, 3 will output a value for 35. What Matlab does is it takes the 2 and it plugs it into the x, it takes the 3, it plugs it into the y. 2 cubed is 8, 3 cubed is 27. We get the output of 35. Now when we create these functions, it's very common for us to need to plot them so that they can be evaluated. One of the main functions for plotting is fplot. It works very similar to the plot function, but the first input is the function itself, whatever you named it. In the example here, it was named fun, and we plot it over a range AB, which is treated as a single input or a 1x2 array showing the minimum and maximum bounds of the plot area. In the first example here, instead of creating a function first, we actually type the function out like an inline function. That's why you see it listed as text in between single apostrophes, but it's important to note that newer versions of Matlab will be phasing this syntax out. The more common approach is to create the anonymous function. So in this example, we say @x, meaning that this function has a single independent variable. We type the expression of the equation itself, which is x squared times sine of 1 over x, and we want to plot it between -1 and 1. Another option, going from 0 to 2 pi for sine of 1 over x. Or there's the easy plot function. Let's look at an example in Matlab. Let's say that x goes from -1 to 1. We'll say y is equal to x to the power of 2 times sine of 1 divided by x. But we want to create a anonymous function with this. So we're going to say @x is equal to this value here. To plot it, we simply use the fplot function. The function we want to plot is y, and we'd like to evaluate it between -1 and 1. When we hit enter, we get something that looks like this. Kind of an interesting function, but this is what the function does. It looks like most of the fun stuff is happening between about -0.3 to 0.3, but treated the same way as the plot function, we could add grid lines. We could say hold on if we wanted more plots. We can create titles the same way, and so on.